one of the engineers working directly on our software for vibration testing. Hi, Phillips, the floor is yours.
Hello, everyone. In this webinar, we're going to talk about vibration testing in automotive. We will discuss standards, technical specifications, common setups, and usual vibration tests, and discuss our customer cases. We're hoping to make this webinar interesting and worthwhile. Nowadays, we can call automotive one of the most developed and yet the most fast-growing engineering spheres. Since the beginning of the 20th century, car industry has changed a lot. And now there are a lot of standards in car production, car testing, and certification. These standards must be followed, so to conform these standards, the car manufacturer needs to test car parts for durability, make structural analysis, find weak parts, improve them, and run vibration tests. Here on the right side, you can see application spheres. Here you see the safety tests, structural and durability analysis, shock testing, road shaking tests, and now e-cars, which are becoming more widespread, have influenced the car industry a lot. So these cars have complicated power supply and electrical engines, which must be tested more strictly. So for this case, we can use shock and vibration resistance testing. All in all, we can say that vibration and durability testing in automotive has grown into a large industry, and RULA Technologies is ready to cater for the needs of this industry. So let's talk a little bit of history of automotive testing. Here in the screen you can see the most important dates in the history of automotive, and let's discuss it. In this picture you can see that in the year 1955 company Ford began testing their cars for durability, safety, and the engineers used special constructions placed on the car and used special mobile data acquisition systems. On this first picture, you can see such bus, a lot of cables going from the testing car. And on the right side, you can see one of the first data acquisition systems. After that, a lot of time passed. So this industry developed, and in 1970, Sine, which is called Society of Automotive Engineers, developed their first standards. These standards were dedicated to safety, engines, materials, different car parts, and now all the standards are used and being developed. In this time period, car manufacturers started to provide crash testing, seat belts testing, and after that, a huge step was made when people started to use PCs, microprocessors in their equipment, and at the same time, vibration testing started to widen its spheres. Vibration tests were introduced as a compulsory part during car parts production. So on the left side of this screen, you can see a car placed on 4 shakers, and it's being tested. After that, with the development of complex and complicated vibration shakers and creation of huge shakers that can hold large load mass, test of whole cars were also introduced. And in the latest 20-30 years, many car manufacturers developed their own testing standards, which include vibration tests. So testing equipment manufacturers rely on the existing standard, but also have to adapt their software, hardware for manufacturers and their demands. And now let's talk a little bit more about the standards. The first standard is done by Society of Automotive Engineers. These standards cover all spheres of automotive testing. Also, it's very important to say about ASTM standards. It's free international testing standards. Also, automotive standards include some kind of corporate standards, like we have a car concern which has their own way of production, testing, and they have special documents to cover this. And I must say that military standards are really important. You know that MIL-STD is a well-known standard for testing some kind of metal constructions, parts, and I must say that the most important standards of MIL-STD are 810 and 202. We can divide automotive tests into three different categories. The first one is crash testing. The second one is data collection and analysis. And the third one, and the most interesting one, is vibration testing. For crash testing, we can advise our portable data recorder, RULA 17. It can be placed inside the car on its part and record all the data during the crash testing. After that, you can use this data to analyze the shocks and process the recorded signal. Another way is the data collection and analysis. We have our RULA 19 portable analyzer. On the right side, you can see a car which has a lot of sensors placed on it, and you can connect these sensors with our analyzer, have a ride and record the data, analyze the road shaking, record the shocks, and so on. After that, you can use our special signal analyzing software. And the final part is vibration testing. On the right side, you can see a car placed on shakers, and to run vibration tests in RULA, we have multiple controllers like RLC21 and RLC25. We have we have amplifiers, and this way, using vibration tests, you can replicate real-time events on your testing object. For example, you can replicate road shaking, bump tests, test the objects for their durability, and even use fatigue damage spectrum. Let's talk a little bit about the setups. For example, we have some kind of a car part, and we can place it on the shaker, mount an accelerometer to the testing object, place some more for data recording on the special places of the part, connect the sensors to our controller, add an amplifier, connect it with the shaker and our system, and connect a PC to our controller. In that case, we're able to test some different car parts. But if you want to test the whole car, we have an ability to run multi-shaker tests. You can add up to 8 controllers into the stack and run up to 8 shakers at the same time. So And using this kind of setup, you can test large objects, cars, and if you have some questions, you can write us and we will try to help you with the setup. And now let's talk a little bit more about shaker selection. It's very important to make a proper decision on shaker, and we have two ways of selecting a shaker. The first one is called servo-hydraulic type of shaker. It's used when we need low frequencies but high amplitudes. They are used during whole car testing. Also, you can use electrodynamic shakers, like shown here on the right side. You can place some car parts and so on this shaker, and we support all types of shakers. In this slide, you can see the most common test types for automotive testing. We have Sine and Multishaker Sine, Shock with its Multishaker version. We have an advanced Sine. We will discuss this option today. We have random and Multishaker random testing, and we have a field data replication. Do we have any questions?
Well, yeah. One question from a viewer: do you have a kurtosis option in random tests?
Yeah, we have this option. I'll show you this during the test setup. Okay. And now let's continue. Our first profile, which I will show you today, is called ASTM D4169. This test is used for replicating the truck shipment. So let's open our software. And here we have an option to create test based on the template. Here you see the standards, and here we see ASTM, and we have random tests. And here we see ASTM D4169 truck profile. We have three different levels of this test, so let's select high level. The test will be created automatically. And here you see the profile. If you want to have other test templates, you can write us, send us a profile, and we will add it to our software. So if you're looking for the quickest way to start vibration tests in automotive, you can create a test template or use a pre-created one and use it for your needs. And here, let's talk a little bit. We had a question about kurtosis, and here we have this option. And here you see that we can add the settings, and it will be used during the test. Now let's go back. The second test I want to discuss is a corporate standard, and this standard is used for electrical components testing. It's a random test. So here, let's quiet it. Our current test. Here we select random. And let's create a new test. But before we start, let me change one setting, because I like to enter random profile not by points, by table. Here we go to the main tab and press create test button. Our starting frequency is 10 Hz and the end frequency of the first line is 60 Hz. Our amplitude is set to the 0.06. Here we have the same amplitude. So we add another line. Here we will run up to 100 Hertz. And the amplitude is set to 0.1. After add another line, and we will run up to 500 Hertz with the same amplitude. After that, we need to add 700 Hertz frequency and decrease our amplitude. And here we will end at 2000 Hertz frequency with a straight line. Let's apply the settings. And here you see we have a profile. Another interesting feature I want to say about is called FDS. FDS is a fatigue damage spectrum. Here on the left side, you see a recorded data signal. Here we had road shaking from quad bike from our previous webinar, and it will be converted into the random profile. And in fatigue damage spectrum test, we will try to simulate a long time force influence for the short time test. For example, we can convert 100 hours test into a 30 minutes test. To do this, let's go back to our test. We will press create test again. And here on the right side, you can see a function called FDS calculator. Here we need to add file. We select our quad shaking accelerogram, and in this text box, we need to enter the time value for replicating, for example, 100 hours and so on. Let's enter something like this. After that, here we need to enter our test duration, for example, 3 minutes. And after that, we need to press recalculate FTS and calculate PSD. And after that, we can create our test profile. Let's apply the settings. Here you see we have our profile lines. Here we have our total test time of 3 minutes. And this test will replicate 27 hours in 3 minutes. So using fatigue damage spectrum, you can test your objects for durability, like car parts, car lamps, lights, and so on. I think it's one of the most interesting and important features in our software, and now we try to improve and develop this algorithm. And the final test I want to show you is called advanced Sine. Advanced Sine is a little bit different from the regular Sine test because we can influence our object at the same time with multiple Sine frequencies. For example, we have some kind of this profile in Sine test, and we need to run this profile for 27 hours. With a single frequency, it's will take a lot of time, like I said previously 27 hours, but using advanced Sine, we can set up to 8 parallel frequencies, which will run the profile at the same time. So we will influence our object with multiple frequencies. Also, let's go back to our software. Here we select our advanced Sine. And I want to mention that this test type is widely used in Germany because it's really good, nice, and it saves you time. So let's create a profile. We will run from 80 Hertz with 6G amplitude. Our end frequency is 110. We have amplitude of 8. Let's add another line. We will run up to 152 Hertz. Amplitude increase will be 10G. Here we have 210 with the same amplitude. After that, we'll go to 290. We'll decrease our amplitude. After that, we need to enter a 400G or 400 Hertz with 7G amplitude. Here we have another frequency with 7G amplitude. Here we have 762 Hertz. And then we will increase our amplitude at this part of the profile. And we will go back up to 10G. And the final frequency is 2000 Hertz. Here you see the profile and the demanded time. Here we will enter this value. So you see that the profile run will take 166 hours. But we can go to schedule and select make multi-tone sweep. Here we can set, for example, the maximum value of 8 and press apply. And we see that our total test time is decreased by 8 times. And that way you can control the tone number. Also, we have an ability to add multi-sign command. That means you can add these two commands and enter different profile commands here. They will run at the same time, so you can add sweep, run profile, hold frequencies, and so on. This is really important because it saves you time. Do we have any other questions?
Yeah, we have a question about types of data analysis. So what types of data analysis can we do and how?
We can provide different types of data analysis. We have a special software for this. It's called this analyzer. We have an octave analysis. We have order analysis, and now we hard work on model analysis and on increasing its number of features. We are adding model hammering sometime, and I think Soon we will release a new version with new features. So for automotive, we have all desired ways of data analysis. And we have also a spectral analysis feature in this analyzer.
Oh, great. Okay, Jay Kumar also had a question, I believe. He raised his hand. So if you have a question still, please type in the question box or answer in the chat, and we'll go forward. Okay.
And so now let's go back to our presentation, because we don't have any questions left.
Oh yeah, I believe.
So now let's make a conclusion. In this webinar, we talked about automotive testing, and we talked that we need safety test, durability and structural analysis, shock tests, and road shaking in this sphere. We also talked a little bit about the history of automotive, and we learned that it has improved a lot. We mentioned that in RULA we have devices and software for all types of automotive testing, and we provide a lot of data analysis features. And we talked about the standards and described the most common vibration tests. And I think if this sphere is really interesting for you, we can create some more webinars for automotive, make some examples about multi-shaker testing in this sphere, and describe it more in details. So I hope you enjoyed this webinar.
Yeah, thank you all for joining us. We'll follow up with an email in a few days, next week, I believe. So enjoy the rest of your day and see you next time.